Hello everyone. So today we will be learning about histograms. Section 2.2 histograms. Okay. Now, as I said you in the previous class that we will be organizing and summarizing data using two things. What were they? One was the frequency distribution table and second was histogram, right? Now we will see how to organize and summarize data using histograph or histogram. Okay. So what is histogram? Histogram is nothing but it's a graph. It's a graph which displays the data by using vertical bars. So the data is displayed in a vertical bars. Fine. So here the horizontal scale will be representing the data values or the classes, and the vertical bars will be representing the frequencies. Okay. And one more thing is these bars or those lines should be adjacent to each other, which means that there should not be any gap in the data. Okay. Now, for example, this is how your histogram will look like. And maybe like this. Okay. So here, this X bar so here X is nothing but your classes. Okay. And the vertical line or the y-axis, x-axis and y-axis. The horizontal line is the x-axis, vertical line is the y-axis. Okay. So x-axis will always be the classes, whereas your vertical bar or the y-axis will be the frequency. Okay. And these bars represent your histogram. This is called as bars. And as I said you, the lines here are adjacent to each other. That means there is no gap. For example, if I draw like this, you cannot do this, which means this is a gap. And this is not a histogram. If there is a gap like this, this is not a histogram. Got it? Okay. So let us learn about this from example 1. This in x-axis and y-axis, right? And as I said you, the classes, this is called as classes. So these values must be plotted on the x-axis, whereas the frequency will be plotted in the y-axis. Okay. Now, if you can see the values here, it is like 50, 69. There are two values in one line. So how do you plot this here? So you cannot plot two lines on the same line, right? On the same part or on the same portion, you cannot plot two points. So that is why we will have to find the what is called as class boundaries. Okay. So what is the formula for the class boundaries? It is nothing but It is nothing but the highest point of the first class and the lowest point of the next class. Okay, 69 plus 70 divided by 2 will give you the boundary line, which is 49 point. Okay. So how do you get this? It is nothing but 69 plus 70 divided by 2. How do you get this? 89 plus 90 divided by 2. And this is 109 plus 110 divided by 2. Okay. So if you calculate like this, your final answer is going to be, class boundaries for this is 49.5, 69.5, 89.5, 109.5, 129.5. Now to calculate this, okay, the last value, we do not know the next value, right? For this, what you have to do is, whatever is the number in the remaining, you have to add zero point 0.5. Always, you have to add 0.5 to the number, which will take you to 149.5. Now, why it is exactly 0.5? Why is it always 0.5? Remember, class boundaries are nothing but the boundary lines. Okay, for example, I am plotting the line here, 50, 69. I'm just uh, writing the same values in a line, 89 and 90, 109, 110, 129, starting from 50 to 69, 70, 89, 90, 109, 110, 129, 130, and 140. Okay. Now, now your class boundaries are nothing but the boundary line here. This boundary, this is one class. This is one class. Okay. So this is your class boundary. So how do you calculate this point? It will always be the midpoint between two numbers, right? So what is the difference between these two? 69 minus 70, it is going to be 1. What is the midpoint? It will be half, which is 0.5. Half of 1 is 1 by 2, which is 0.5. Okay, and that is the reason we add 0.5 at the end. Okay. So let's get back to the problem. Now we know the class boundaries. So now we will be plotting that here on the line. So this is the first point, 49.5. Next point is 69.5, 89.5, 109.5, 129.5, and the last value is 149.5. So this is your x-axis, which is nothing but classes, and the label for the classes in this example is IQ scores. Okay. Now, vertical axis. How do you do this? Now remember, just know the highest point and the lowest point. So lowest point starts from 1 and your highest point is 35. So your ending number should be less than, should be around 35. Now for example, I can take like 10, 20, 30, and 10, 20, 30, and 40. Can I take it as 5, 10, 20, 30? Yes, you can. Okay. It has nothing. It has nothing much to do with the uh, concept. It is more of your convenience. Okay. Now let's see how many of them have the IQ scores between 52 to 69. So this line is your first class. Okay. So how many people has the IQ score between that? It is 2 people. Number of people is 2. So which means it will be below this line, right? So it will be 1 might be here. From here to 69.5, the frequency is 2 and the IQ score is between 50 to 69. Now 70 to 89. How many people have the IQ score between 70 to 89? It is 33. So where do I have my 33 on the vertical bar? It will be between 40 to 30. Somewhere here. You cannot draw, you cannot find the exact point while you are drawing without a graph. So let's say here. So this is my 33. Just draw a straight line from here. So from here to 89.5, it is same. So that is why we are drawing the horizontal line here and then just drawing the line. Okay. And next, it is 35, slightly above than this. Next is 7, which is less than 10. That is going to be like this. And it is 1 less than 10, so 1. Okay, this is your histogram. This is for 1, 7, 35, 33, and 2. Okay, so this is how you plot the histogram. Now, what if they have given you, instead of frequency, what if they give you relative frequency? Then only change is that it will be same thing, but the vertical bar will be in terms of relative frequencies, in terms of percentage, rather than the actual frequencies. Okay. Now let's calculate relative frequencies. So for that we need summation of L, which is sum of all frequencies. So here it is 78. How do we find the relative frequency? The formula is F divided by N. N is nothing but summation N. Okay. So here F is 2. So it is 2 divided by 78. And next it is 33. 33 divided by 78. And 35 divided by 78. 7 divided by 78 and 1 divided by 78. So if you calculate this, you will get in a decimal format, convert that into percentage, which is multiplying by 100. So I will write the final answer, 2.6. Remember, this is in percentage. One point. Okay. So how do you plot? You will be using the same method. This is your x-axis, y-axis. So horizontal line should be having the classes, which is IQ score, which will be starting from 49.5, 49.5, 69.5, 89.5, 109.5, 129.5. This is the last point. That is 149. Okay, and your y-axis will be, so let's see, the highest point is 44.9, which is 45. So I can say that I can start from 10 again, 10 percentage, 20, 10. So 10, 20, 30, 40, mm, or even say 45. 45 is the most. Okay. Now, okay. So now this is your relative frequency. Okay, this is your relative frequency. Now, how do we draw the histogram? In the same way. So here the percentage is 2.6, which is below 10 percentage. So it will be around here. And next is 42.3. So it will be somewhere between 40 and 45. So somewhere here I can see. And next is 45 or 44.9. Roughly it will be 45. So which is the highest point. And next is 9, which is less than 10, which is less than 10. So I'm going to draw here. And next it is 1.3. 1.3. So this is your histogram. This is 1.3 and this is 9, 44.9 percentage, 42.3 percentage, 2.6 percentage. Okay, remember these are the percentage values. So these are this is how you draw the histogram. Okay, using when they have given you actual frequencies and when they give you relative frequencies, you can draw the histogram. Remember, I told you the histogram definition that the horizontal line will have the number of classes and the vertical line should have the actual frequencies. Now, this is frequency and classes, so this is called as histogram. Okay, here there is a classes, but you do not have actual frequencies, rather you have relative frequency. So what is this histogram called as? This is called as relative frequency histogram. Okay, this is called as relative frequency histogram, which has the same shape, same horizontal scale, but only difference is with the vertical bar. If your vertical scale is marked with relative frequencies, then the histogram will be called as relative frequency histogram. Okay. Now let us learn about some terminologies which is very important. Okay. So here C stands for center of the data, V is nothing but the variation, D is distribution, O is outliers, T is time. What is center of data? So a center of data is nothing but it's a value which shows where the middle of the data set is located. Okay, that is called as center of the data. What is variation? Variation will measure the amount that the data values vary. What is a distribution or a shape of a distribution? So it can be anything. It can be of any shape like a bell-shaped, uniform, skewed. We will see about this in a moment. Okay. Outliers. Outliers are nothing but there will be some values which lie very far away from your sample values, from your other sample values, which means that, for example, you may have frequencies like this, frequency like this, 2, 4, 100. Again, it will be 1, 2. So this here 100 is called as the outlier, which means the sample value which is very far away from the actual or the other sample values, right? 100 is very far away from 1, 2, 4, and 2. So that is called as outliers. Time, when you record your data with respect to your time, that is called as time. Okay. So let us see a few examples or few shapes of the distribution. So first thing is bell shaped, uniform, skewed right or left. These are the main or commonly seen distribution shapes. Okay. Now, bell shaped is also called as normal distribution, right? So here, as you can see, we call it as normal distribution because it will start from a low point. It is starting from a low point and it will increase. It is increasing. It will increase to a maximum point and again it decreases. It decreases and reaches the same lowest point where you started. The lowest point here and here will be same. And the points here, all these points are same. So since it is symmetric or it's like a mirror of each other, so this is called as bell-shaped curve. Okay, you will be seeing more of this. This is the most commonly used or seen distribution shape. Okay, next is skewed right. So here, as you can see, it is increasing. It is increasing. It reached the maximum point and then it will all decrease to a lowest point than the point here, right? It decreases at once. So this is called as skewed right. So where do we use this? So for example, say that we have a football team players whose salaries are low when it is compared with the other star players. Okay, so assume that this is a football team, these are the players, and some players will have the salaries which is less than the star players. So star players will be here, somewhere here, and the other players are here, right? So that is one example I can give you about skewed right. Skewed left is similar to the same uh, this shape where it starts from the lowest point and it increases rather than decreasing, it increases. So that is called your skewed left. Skewed left. Okay. For example, I can give you the COVID cases. So at the start, even before the COVID was known for everyone. So at that point of time, the COVID cases were only less. It was a low thing, right? So, and gradually it increased. So that is one example I can give you for skewed left. Uniform. which means there is no change in the data set or the frequencies. There is no change in the frequencies or number of people. For example, I can give you like this. For example, we are conducting three tests, right? We'll be conducting three tests. And in test 1, I will see 60 students. And in test 2, I will also see 60 students because they need a grade. So definitely I will see 60 students in all the tests, in all the three tests. So which means the frequency is same. This is an example for uniform shape. What is bimodal? So bimodal is nothing but you will have the same histogram twice. Okay, so it will repeat. If it is repeating, that is called as bimodal. For example, this is for uniform. For bimodal, I can give you example for of number of customers visiting restaurant. So usually people go to restaurants during, more often they go during lunch and dinner time, right? So assume that this graph is for lunch and this is for dinner. So you will see the same number of people during these times. And that shape of graph or the curve is called as bimodal. Okay? And this is another example for skewed right, where it increases and then it keeps on decreasing. Okay. Next is about normality or the QQ plots. Okay. So you will, as I said you in the earlier class, how do you find the normal distribution, or what is a normal distribution? It is nothing but if your frequency starts from low and it reaches maximum point and it gradually decreases and reaches the same lowest point, and it is symmetric on both sides, then it is called as, that distribution is called as normal distribution. Now sometimes if you cannot plot the bell-shaped graph, if you are plotting in terms of x and y, if there is a line plot and you want to know the if you want to know the normality, how do you find? So this type of graph or this type of plot is called as QQ plot. Okay, so you can find the normality like this. Suppose if the distribution or the points, these are called the data points. Okay, these are called as data points. If these data points are very close to the straight line here, this is called as normality line, normal line or normality line. If the data points are very close to the straight line, then we say that there is a normality. The distribution is normal distribution. If the points are very close to the straight line and there is no systematic pattern, which is not a straight line, then we call it as, then this distribution is a normal distribution. This is one example. Here, as you can see, the data points are not even close to the straight line. See, right? So this is not at all a normal distribution. Your data points should lie around or lie along the straight line. Now here, if you can see, the data points are very close to the straight line, but this is not a normal distribution because if you join these points, you can see that it is not a straight line, right? So the data point should lie close to the straight line and should also reflect the same shape. It should lie along the straight line, and it has to be a straight line also. So then we call that distribution as normal distribution. Okay. Now let us learn more about. So let us learn more about this CVDO. Now, let me give an example. So let's say that Elizabeth is on a science project and she wants to know how many times the bleach, how many times she is experimenting something that she wants to know how many times the bleach will remove the stain completely. Okay, and a frequency distribution table looks like this. This is the type of stain, and this is a number of times the bleach can remove it. Okay, for example, we have ketchup, grass, mustard, dirt, grease, ink, and pot. Now, the number of her experiment or will be like this. Okay, now she likes to know the center of data. Why? And why is it important? Because a center of data is nothing but it's a single number that summarizes the entire data set. Now, if she wants to know how many times the bleach can remove the stain completely in by using just a single number, it is going to save a lot of time, right? So in total, I want to know she wants to know that how many times the bleach can remove the stain completely. Okay. Now, so now how can we find the center of data? How can we find the center of data? So center of data can be found using two things, mean and median. Okay, you can use anything. You can use mean and you can also use median. So more often we use mean, or it is also called as average, when there is no much difference, when there is not much difference between your frequencies numbers, then we use mean. So here, as you can see, it is 4 5 5 4 1. So there is not much a big difference between those frequencies, so we will use mean to find out the center of data. So mean is nothing but your average. So what is the formula for mean? It will be sum of the numbers or the frequencies, sum of the numbers or the frequencies divided by total number of frequencies. Okay. Now remember, here sum of the numbers is nothing but 4 plus 5 plus 5 plus 4, 1 plus 2 plus 3, divided by how many numbers do we have? 1, 2, 3, 4, 5, 6, 7. So 7, which is nothing but 3. So your average or mean is 3, which means this is also called as center of data. Now, what if I get the center of data as 3? What does that say? This says that on an average, the bleach will effectively remove the stain 3 out of 5 times. Okay? Out of 5 times, it will remove the stain effectively 3 times. So this is what you wanted to know. And this is why the center of data is very useful. Okay? Next is the variance. What is a variance, or what does that say? Variance will be a measure of how dispersed or spread out the set is. Okay, so this mean and median which we discussed now, the center of data, this will not say, or this will not measure the spread out of the set. So variance is the one which measures that how spread out the set of data are, or the values are. Now, why do I want to know that? Why do I want to know the variance? For example, if I say that the variance is 0, what does that mean? If I say the variance is 0, that means every member, which means every member of this data set is the same. If the variance is 0, that means there is not much difference in the data values or in the frequencies. If the variance is 0, that means that every member is same. It is like more of a uniform shape. So if you have a uniform shape, then we say that variance is 0. And next is distribution. So we saw the different shapes of distributions. So let's move on to the next point, that is outliers. So outlier is nothing but a data point or a data value. It's a data point that differs significantly from other data points. So now why does this happen? Why do we get a data point which is different from the other data points? It can be experimental error. Okay, so suppose, as I said you in the beginning, if you have a value which is way different from other data points, then that value should be a mistake, right? If you are doing the same survey, then the data points should have some relationship between them. You cannot have a point which is very much different from the other data points. So if you have, then that means there is something wrong in the experiment or in the survey. So outliers are very helpful to find out these type of points. So this is pretty much about your section 2.2 histogram. So what did we study? We studied the definition of histogram, and we saw an example where we can draw a histogram using the classes and frequencies. Now if you have relative frequency on the vertical bar, it means that that type of histogram is called as relative frequency histogram. Okay, and we also studied about the CV dot, so that is center, variation, distribution, outliers, and time. And we also studied about distribution, different types of distribution shapes like bell-shaped, bimodal, uniform, etc. And then we also learned how to find the normality using QQ plot. So QQ is called as quantile plots. Okay, Q stands for quantile. And then we have some examples for explaining CV dot and why do we need those terminologies. Okay, so this is all about your section 2.2.